Well, welcome to another fabulous flip lesson in math class from Mr. Moore and Mr. Rockenstein's class. Today we're going to talk about simplifying fractions and then also finding equivalent fractions. So we're going to get right to it. You'll notice for simplifying fractions, there's just a few rules to think about. One is whatever you do to the numerator, you also have to do to the denominator and vice versa, meaning if we did it to the denominator, we also have to do it to the numerator. So if we're dividing by 2 to the top number, we also have to do that to the bottom number. Another rule is factors, or numbers that fit into bigger numbers equally, are the keys to simplifying. So really we're just going to try to find common factors in order to simplify. And then one of the last rules is start with easy numbers. When you're simplifying, there's no reason to have to get to the end result right away. You can do it a couple steps if you need to. The last key, and I have it just written over on the side, is simplifying fractions is just dividing. All we're going to be doing is dividing fractions with a common number, a common factor in order to get a smaller answer. So if we start right away with our fraction 3/9, we're looking for what number can we divide into 3 and what number can we divide into 9? What numbers work? Well, I know 2 doesn't work because I need an even number. Does 3 work? Well, yeah, 3 fits into 3 and 3 fits into 9. So I've started with an easy number and now I have to do it to both of them. And I'm going to divide in order to simplify. So if I did 3 divided by 3, I get 1. And if I do the same thing to 9, 9 divided by 3 equals 3. So I've followed all my steps, really easy. I did the same thing to the top and the bottom. I divided. I started with an easy number and I found a factor that fit into both of them. So simplifying 3/9, it could just be 1/3. I can't go any further with this one because that's as small as I'd be able to get it because I've hit a prime number. Once I hit that prime number, I'm done. If I look at another example, here's 15 and 20. Well, could I start with the number 2? Just like we talked about, it's a small number. 2 fits into 20, so that would work there, but 2 doesn't fit into 15, so I can't start with that one. What about the number 3? I could do the number 3 fits into 15, but it doesn't fit into the number 20, so I got to go up from there. Number 4, that fits into 20 but not 15. 5. 5 fits into both of them, so I'm going to choose 5. So 15 divided by 5 gets me 3, and 20 divided by 5 would get me 4. So if I simplified 15/20ths, it equals 3/4. So we've got a smaller fraction. Here's another one. I have 16/20ths. Well, I start with my easy number, 2. 2 fits into both of them, so I'm going to do that for this one. 16 divided by 2 and 20 divided by 2. 16 divided by 2 equals 8, and 20 divided by 2 equals 10. But it's not the smallest I could get. I could simplify it even further. So I'm going to divide by 2 again. 8 divided by 2 is 4, and 10 divided by 2 is 5. So now I've hit a prime number. I can't go any further. So 16/20 equals 4/5. Another way that we could have gone with that is just to divide by 4 right off the bat. 16 divided by 4 is 4, and 20 divided by 4 would have been 5. And so we would have gotten that same answer. So that's as simple as simplifying. Now if we move on to equivalent fractions, the rules are almost the exact same. Whatever we do to the numerator, we have to do to the denominator. So if I do it to the top number, I have to do that same action to the bottom number and use the same numbers. It's the opposite of simplifying fractions. So instead of dividing, we're going to be multiplying here. And instead of getting a smaller number, we're usually going to end up with a bigger number. And then you can still use easy numbers. There's no reason to use these huge numbers in order to find our equivalent fraction. We can just as easily use some small numbers and it gets us the answer. So same thing I'm going to go with. Equivalent fractions. I want to make a bigger one. Well, I'm going to go really simple the first time. I'm going to multiply the top and the bottom by 2. So 1/3, 1 times 2 is 2, 3 times 2 is 6. There's an equivalent fraction. That means 1/3 is the same as 2/6. Now I could go another step and multiply by 2 again, and I end up with 4/12. Well, that means 1/3 is the same as 2/6 is the same as 4/12. They all equal the same thing. Because I did the same thing to the numerator and the denominator and used the same number, I end up with the same fraction. It's just bigger ones. So One more example, I have 3/4. Well, let's, instead of doing a smaller one, let's do a little bit bigger. I'm going to do 10 times 10 and times 10. Following my rules, have to do the same thing to the top and the bottom. I'm multiplying. This time 3 times 10 would be 30. 4 times 10 would end up being 40. So that means 3/4 is the same as 30/40. It's an equivalent fraction. As long as you're doing the same action to the numerator as you do to the denominator, you're going to end up with an equivalent fraction. And so we could also, with equivalent fractions, go the opposite way, like simplifying. Simplifying really is just finding equivalent fractions. So if I had 30/40 and I needed to find an equivalent fraction, I could divide by 10 now this time in order to find my equivalent fraction, and it would be the same thing. Going backwards, simplifying fractions is finding equivalent fractions. But that's really all we have. So hope this makes sense to you. Hope you understand. Remember, you have to make sure you do the same action to the top and the bottom numbers in the fraction. Simplifying, you're going to divide. We want to get to the smallest possible numbers. And finding equivalent fractions, we can go both ways as long as we do both actions.